Hello, Honor Chem students. A quick video, introductory video for the new chapter, the new unit we're starting, which is solutions. Chapters 12 and 13 are what we will be covering in this unit. And when we talk about a solution, there's two terms that often are used at the beginning of any lesson in solutions, and it's homogeneous versus heterogeneous. And a solution is a mixture, and the mixture can be uniform or it could be in layers. So if we look at something like a heterogeneous mixture, you'll notice that there's a layer here of one type of the component versus the layer of another. That would be considered a heterogeneous mixture, where a homogeneous mixture, you'll see that the picture has the components evenly intermingled between them. And these are mixtures that exist in our everyday life. You can consider something like oil and vinegar in your salad dressing would be considered to be a heterogeneous mixture, whereas a homogeneous mixture might be the Gatorade that you drink. So those are some examples of homogeneous and heterogeneous mixtures. We have components that are in a mixture, and probably one of the most common that you know of is salt water. Here you take salt, you put it in water. These would be the two components, and then what you get is a mixture of what we would call salt water. Now, we're going to talk later in a different time in this unit of really what is happening. You'll notice that these turn into ions, a sodium ion and a chloride ion, and we'll be talking about that later on in the week. But just right now, know that a mixture is two components. It could either be homogeneous or heterogeneous. And in this picture right here, salt dissolving in water is example of a heterogeneous mixture, which we will call a solution. So a solution is a homogeneous mixture in which the compounds are uniformly intermingled. A solution is made up of two components. The two components that you should know are solute, and the other component is the solvent. So if we add a solute and a solvent together, they will make a solution. So this picture that I had shown you right here is actually a sodium chloride solution. And since it's dissolved in water, we would say that it's an aqueous solution. So a solute is what is dissolved, and typically it exists in a lesser amount. A solvent is what does the dissolving, and typically that exists in a greater amount. So if you go back to our picture here you've got a pile of sodium chloride. Notice its volume isn't as large as the volume of water. So that's what I mean about typically this is in a smaller amount than what the solvent is. And together a solution is both components of the solute and the solvent. There's many different types of solutions in our everyday world. You guys were reading or watched the videos about the lakes, one in Africa, one here in the United States. Those are examples of solutions, that there's a gas-liquid combination. Probably the more common one that you might not even think of is soda pop. Soda pop is a solution that has a liquid state, which is typically the water. There's dissolved sugars in there, so you could call that also a solid liquid solution, with sugar in the water. But there's also carbon dioxide gas in the water, so it is definitely a solution. There can be liquid solutions like alcohol is being dissolved into water. There can be gas solutions like oxygen and nitrogen, or if you think of even the air we breathe, we know that the air is a mixture of nitrogen and oxygen and carbon dioxide. There can also be solid mixtures. In this example here, they're saying copper and nickel, or what I'm going to talk about is gold. We know that pure gold is a pure element. That's what we call 24 karat gold, but it's not really all that practical to make a wedding band out of 24 karat gold because it's very soft and malleable. So they strengthen that by calling and making a 14 karat gold band, which is really an alloy that has silver and also copper mixed in with the gold atoms. So that's what we call an alloy, and that is definitely considered to be a mixture. A couple other terms that you should know about are what we call insoluble. Insoluble would mean that the two components do not intermix. And so I would say, like oil and water, we know is insoluble. They do not intermix at all. And another example of this would be like the oil and vinegar in your salad dressing. Whereas something that is soluble here, as you can see, represents an intermingling and it's uniform. So that would be considered soluble. So there's a difference between being insoluble, where they do not intermingle, and what we would call soluble. And then two other terms that you should be aware of in terms of liquid components. So like when we talk about a liquid-liquid mixture, we use the term immiscible, which means that because of the structure of this molecule, they do not intermix. And we'll talk more about why that happens tomorrow in the next lesson. But I may bring back this slide, but it's good for you just to know this terminology too. Immiscible means that it is insoluble. They do not intermix in a liquid-liquid form. And actually, if we expand this picture here, so let's see if I can actually expand it here a little bit, you can actually see there is like a meniscus between these two liquid materials, and that's what we would call and say they are immiscible. Compared to something that is miscible, that means that they do intermix. And an example of that would be ethanol and water. They intermix and you don't see a mixture line in that at all. So we would say that they are miscible. So there's just some terminology. I'd also recommend, and I know that we haven't been putting it in our notes, but you definitely should be reading the two chapters. So if you have any questions about this terminology or more wanting to know more information about how they interact, make sure that you are reading the front part and the first, I'd say, 2 sections of chapter 12. That's great, and you can move on to the next learning. Have a great day.